All right, guys. So again, this is page 106. Everybody. Every single person. All right. Or who identifies a different organism. If you're in this class and alive, shut up. So number 3, PEMDAS will always save your ass. It will. What's the last thing I'm going to do on number 3?
Subtract.
What?
Subtraction? Well, I guess that sort of is right. That's the last thing I would do here, is because there ain't no subtraction happening. Maybe I should rephrase. Out of the operations that are here, which one's the last one I'm going to do?
Division. Just name it.
All right, let's try it. All right. What's the first thing in order of operations? Parentheses. Inside the parentheses. So what's outside the parentheses? Yeah, that's probably a thing I'm going to do last. Because order of operations says do the inside first. Okay. Alright, that's a good start. So what the hell can I do on the inside? Yeah, there's no like bases inside, right? The only thing that I need to do inside is take care of the negative powers. So which thing inside here is not gonna flip? Yeah, Q stays where it is. The 3 R's come up top. Q's just sitting there. And the 4 P's, thank you so much. 4 P's. My Q. My Q is eternally evolving. Let me stop there for a second. Now you could distribute the negative 2 in there, but my God, I want to show you how to avoid that, because that gets kind of gross sometimes. Believe it or not. So do what you can on the inside, and now the negative 2 power. The inside's done. There isn't anything else I can do to the inside. The negative 2 power tells me to do 2 things. The negative part tells me to flip it, and the 2 part tells me to square it. Right? Let me try to say this again. So that negative 2 power, it says to do 2 things. If it was just a 2, I would square everything. If it was just a negative 1, I would just flip everything. So it's a negative 2, so I got to flip everything and then square everything. So let me do that one thing at a time. First thing I'm going to do is just flip everything. So now it becomes what?
P.
Yeah, P4.
Over
Q, Jeff. There you go, Jeff. My Q is never the same. And what's outside now? A 2, because I did the negative part. His job is done. I flipped everything. And now all that's left to do is to square everything. So what do I get? P to the 8th. R to the 6th. Q squared. So again, you see how those 3 R's went up top, the 4 P's went down, the Q stayed right where it is. Why would the Q move? And you're all like, I don't know why, Jeff. No question. I'm just re-explaining what I did. First step was inside, I moved the P and the R's, because those were to a negative power. Inside, all done, so now I do the outside power, following order operations. So the outside power said flip it and square it. All right, cool. I'm done. Yes, yes.
So I did a little differently, but I still got the right answer.
Sure.
Because even negative 1 power is fine, negative 2 is already positive, can I just leave it on top because it's a positive? And
Yeah. So you could totally distribute that negative 2 all day long. And then it's only the Q that you got to flip. What I'm trying to tell you, though, in general, it's so much better to simplify the inside before you apply that thing. I want you guys to get used to it. This one is almost the same either way you do it. But if there was stuff to do inside, I'd much rather simplify the inside and then bring the outside power in. There's less stuff to do it to now. Maybe. So there are always multiple ways to do a problem. So sure, if you distribute the negative 2 through, it'll work the same way. What about number 4 then? Do the y's cancel out? Why do they not cancel out? Because they are not the same. Something divided by itself cancels and becomes 1. That is not something divided by itself. So on the inside, how many x's are left? Where? Top. What do those 2 y's want to do up here? They want to go down. So I desperately, in general, the first thing I do on a problem like this is find any negative powers inside and move them. That's removing the negative mistakes I could make. So those 2 y's want to go down. How many y's are down there already? So when those 2 come down, there's going to be, let it be that easy, please. There's 2 y's here. These 2 want to come down. So now there's going to be 4 y's down there. It's amazing. It's almost, some of you guys are like, this ain't algebra. I don't know what this guy's doing. Yeah, this is algebra. And on the outside, it's still got that negative 3. Whee! Now again, you could distribute the negative 3 first, but then you got 4 things to do it to. Now I only have 2. In fact, I'm not going to distribute it. I'm just going to look at it as 2 commands. Negative, flip, 3, cube. Right? It makes it so much better. Is everybody cool with what's happened so far? So inside I had x squared over x, and x cancels, it leaves me with 1x. Those 2 y's went down, there are already 2 there, so now there's 4 down there. So now I flip it, and I still have to cube it. What do I get when I cube it? Oh my gosh, zoom out. Y to the 12 over x to the 3rd. Now yes, there are other ways to do it, and yes, you will get the same answer if you do those other ways correctly. I'm just trying to show you the way that's most generally easy.
One of the y's would have been like -3. Would it have been a negative answer or still positive?
So if, you mean if the top y had been negative 3?
Like a bigger, or not bigger.
Well, no. If that would have been negative 3, then 3 y's would have gone down, and then there would have been 5 y's on the bottom.
And it's still been positive.
Totally. All right, so the step I'm sort of skipping with the y's, let me just write what I got here so far. That's done over there. Just to show you, these would go down, wouldn't they? These 2 y's here, they would flip down. Is that cool? Because that's what a negative power tells you. They go to the other side. So if I rewrite this, it'll be x over y squared, y squared. Well, what's y squared times y squared? Y to the 4th. So if it would have been y to the negative 3, there would have been 3 y's that went down. There would have been y to the 5th on the bottom. So my whole point is, if it's a negative power, you flip it, it becomes positive. There are no negative powers left. You're not going to make a negative mistake. Again, I'm really good at math, but if I can avoid negatives, I will, because that's one place where the human brain can make a mistake real easy. 3 minus negative 11, holy shit, the brain kind of goes sideways sometimes. Here, you guys try this one. There it is. There. I'm trying to find a curve microscope.
I know, right?
By the way, real quick, if you came in a little late after I said this, I'm not feeling the greatest, so about 10 minutes maybe. I'll let most of you guys out. If you have the lab after this, it's kind of officially canceled. You're going to take a quiz in here, though. Don't get too excited. Oh, some of you guys got so excited for a second. Oh, you still know. You should be excited. You still get to take the quiz. Yay. So if you have lab after this, you're going to stay here. Everybody else is going to leave. And you're not going to feel sad because you're going to get to leave when you're done with the quiz. So just get over it. Be all happy that your teacher's all feeling bad. Yeah, he just sick. Let's go. All right. Now, to be honest, this problem's a little bit nicer than the ones we just did because there's no outside power. Alright. So even before we do anything, yeah. How many things are going to flip?
Well,
Three. So, let me not worry about this yet. So those 4 M's, these 4 M's are going to stay. Those 4 M's are going to go down. These are basically going to switch places. Is that cool?
Yeah.
Those 2 ends want to flip up. Those 5 ends want to flip down. So what do you get for the numbers here?
1/3.
Yeah, 1/3. And what about the M's?
1 to the 8.
That's crazy.
And then
How many N's cancel?
3. 2.
2.
Sorry.
How many are left?
3.
Where?
On the bottom.
Bottom. Now guys, real quick. I really want you to realize, of course it's this easy. When I divide like bases, I'm going to lose some of them. Where will they be left? Where there were more to begin with. So if I wrote this out, n times n over n times n times n times n times n. 2 n's do cancel. 3 are left on the frickin' bottom, right? Please let it be that easy. Now what is 2 minus 5? N to the negative 3, and then you have to flip it, and then you finally catch up with just doing it this way, right? You don't have to bring negative powers in. You guys see that? Please. So sometimes properties and rules are the long cut, right? And you're like, well, there's a shortcut here. Just realize that 2 of the ends go away, and there's 3 left where there were more of them to begin with, of course, right? So there's going to be 3 left on the bottom, and that problem is done. That kicks ass. So move the negative power stuff so you don't make a negative mistake, and then just attack it the way we did. Attack the numbers, check. Attack the ends, M's, the ends, attack them alphabetically, right? Attack each variable one by one. That's breaking the problem down into parts. Okay. All right. The last little piece we have to go over here. Yeah, let me not go there yet. For section 5.2, I think this is still. Scientific notation. So, it's kind of related to the guy that had to write x times x times x times x times x, and he's like, oh my god. And that's where they came up with exponents. Well, what about somebody who has to write 80, 0, 0, 0, 0, 0, 0, 0, 0. It's like at some point you go, these freaking zeros are just shit. They're just telling me how big the number is. There's got to be a quicker way to say there's an 8 followed by a whole bunch of zeros, right? There's got to be a better way to do that. So now watch. I'm going to show you an example of why this notation works the way it does. Show you two examples. All right, so we got 8,000. Let's see. Jake, shut up. All right. 8,000, what is that? That's 8 times what? 8 times
10 to the third.
Let me catch up to you. It's 8 times 1,000, right? I mean, that's just the true statement. And 1,000 I can write as 10 to the, there it is, yeah. That is scientific notation. That's, I say something very strange and I don't care. I kind of like to look at it this way. I suck all the tens out of a number. Have fun with that. So, I'm left with a digit that's between 0 and 9, right? It's actually between 1 and 9. Because I've taken all the tens out of it. So this is sort of telling me the place that the 8's in. This is what's called expanded notation from Math 88, right? And then I just go one step further and I just collected all those tens together. There are 3 tens. And I noticed something interesting. Where's the decimal to begin with? Here. How many times do I have to move it to get it after the 8? 1, 2, 3, yeah. All right, so I mean, most of you guys know scientific notation already. But just in case it's been a while or whatever, this is going to become a shortcut for us so I don't have to do this all the time. I just go straight to 8 times 10 cubed. Now notice this is a positive power. This is almost a silly thing to say because I am multiplying by so many tens to make it a big number. I always had trouble with left and right. I still do. So I'm driving, somebody's giving me directions, I do this. They say turn left, the one that's an L, I turn that one. I got a lot of other shit up here, so I don't care to admit that. I know a lot of other shit, but this I got trouble with. So let me give you a different example. The other way, a small number, 0.008. Somebody help me out. What is 0.008 as a fraction? 8 thousandths, right? Tenths, hundreds, thousandths. And 1,000 we just figured out is 10 to the third. But I want to write it in the same format as that. I want it to always be number times 10 to the number. Exactly. If I force those 3 tens up, they're going to become negative because they don't like it up there. They like it down there. So I can write this as 8 times 10 to the negative 3. Notice how this notation is the only notation where we use x to mean multiplication still. It's just a part of the notation. So this is what I'm saying. If it's a big number, bigger than 10, I'm going to have a positive power. If it's a small number, smaller than 1, I'm going to have a negative power. Now to me, that's even better than left and right, even if I knew freaking left and right. Because if it's a negative power and I have to write it this way, I make it small. If it is a small number, I'm going to make it a negative power. It's beautiful. Let it be beautiful. So for example, let me do one the other way. How would you write 6 times 10 to the negative 7 in decimal form? You have to move the decimal back. You have to make it small. Not left and right. Don't confuse poor Jeff. You got to make it a small number. So you got to move it 7 times back, right, guys? Because it's all about powers of 10, and every time I do a power of 10, I move the decimal once. This is negative, so I'm going to move it back, make it small. So the beautiful thing about negative powers is I always got to move it once to get it around the stupid number. So then how many zeros do I put in front of it? 6. 1 less than the power. It's awesome. Right? So this is just going to become 0. 1, 2, 3, 4, 5, 6. 6. Jeff can count. Jeff is high in confidence. Alright. So what about, let me give you one that's a little bit different. 4.13 times 10 to the 6th. Don't say anything out loud, just write that in normal number form. What we call decimal form.
Chew.
Bless you.
Thank you.
That's a slow motion. Yeah. Is it too much? So you can do the same kind of thing here. I've got to move it once, twice to get around there. So how many zeros after that? Because I've still got 4 more places to go. So it'll be 4, 1, 3, 1, 2, 3, 4. Full million. I like it. Alright, I'm going to let you guys read the rest of it. If you are in the... You're free to go unless you're in the lab after this. There will be no lab after this. You're going to stay here right now and take a quiz.
And then after the quiz, we're just going.